Welcome to section 8.1. Today we will be able to translate an English phrase or sentence to a corresponding expression or equation. And we'll also solve some application problems, which is a fancy phrase for we're going to solve some word problems. The first exercise is we want to write each of the following statements in algebraic form. Question 1. 2 more than a number. A number is an unknown variable, so we'll give it a name. We'll call it x. So I want to have 2 more than a number. That's going to translate as x plus 2. We have 2 more than this number x. Now you're welcome to pause the video and try the rest of these on your own, and then we could check our answers. After you have attempted all of these questions, let's work on it together. Number 2, square root 2 greater than a number. This is very similar to the first one, except we're using the square root of 2. So I'm going to write x plus square root of 2. This is the square root of 2 greater than a number. Number 3, 2 times a number. This implies multiplication. Multiplication with x. So this is 2x. Number 4, a number times itself. This is a number multiplied with itself. So I could write x times x, or I could write x squared. These are both equivalent. Number 5, the cost of renting a car for any number of days if the charge per day is $40. So we'll need multiple variables in this problem. Let's say the cost, I'm going to use the letter C. The number of days, we'll use the letter D. And we know it costs $40 per day. So we're going to create an equation. This is the correct equation. C is equal to 40 times D. For each day it costs $40. So for 2 days you can plug in a 2 here, and 2 times 40 is $80. So this equation holds true for the number of days if it costs $40 per day. Number 6, the distance a car traveled at a constant speed of 65 miles per hour for any number of hours. We'll let D be our distance, and we know that there's hours involved, so we'll use the letter H for hours. This equation is very similar to question 5. We're going to put distance is equal to 65 times H, because I'm traveling 65 miles per hour. So I'm going to multiply the hour times 65 to figure out how far this car traveled. So this is our equation. D equals 65 times H. Number 7, one weekend a store sold twice as many CDs as full-size DVDs and 25 fewer mini DVDs than CDs. If the store sold D full-size DVDs, how many mini DVDs and CDs did it sell? For question number 7, make sure you read this multiple times so you can understand what we're doing. The first piece of information that I need is how many full-size DVDs we sold. We sold the amount of full-size DVDs. So I'll write that down here on the corner. DVDs, we sold the amount. Now we also know we sold twice as many CDs as full-size DVDs. That implies we sold 2D. That's twice the amount of DVDs. Now, how many mini DVDs did we sell? Well, we sold 25 fewer mini DVDs than CDs. So we're going to look at the mini DVDs. So we'll write mini DVDs. And we sold 25 fewer. Fewer than what? The number of CDs. Well, we know the number of CDs is 2D. And we're going to subtract 25 because it's 25 fewer. And there you go. We know the amount for each of these items. Question 8. French fries have about 12 calories apiece. A hamburger has about 600 calories. John is on a diet of 2,000 calories per day. Number 8. French fries have about 12 calories apiece. A hamburger has about 600 calories. John is on a diet of 2,000 calories per day. If he ate F French fries and 1 hamburger, how many calories can he consume that day? Well, I'm going to start with 2,000 because that's the maximum calories we can consume per day. And then we'll subtract how much food he ate. So we have 1 hamburger, so I'm going to subtract 600 calories for that hamburger. And then I'm going to subtract 12F because we're going to consume 12 calories per French fry, and he consumed F amount of French fries. So that's 12F for the French fries, and this is going to give us our final calorie count. And so I'll give this a name. Let's just call it C for calories left that he can consume that day. Let's try some problem-solving questions. Number 1, take any number and add 15 to it. Now multiply that sum by 4. Next, subtract 8 and divide the difference by 4. Now subtract 12 from the quotient and tell me the answer. I will tell you the original number. Now, how are we going to do that? Well, this is a question where you would ask a student to perform these operations, and magically within seconds, you as the instructor will tell them their original number, and they'll be impressed how fast you found their original number. So let's get started with the problem. I will take it step by step. The first thing we want to do is take any number and add 15 to it. So I'll give any number a name, let's call that X, and we'll add 15 to it. Next, we'll multiply that sum by 4, and you want to be careful, let's make sure we have parentheses because we're multiplying the entire sum, X plus 15, by 4. The next step is to subtract 8 from this, and then we're going to divide the difference by 4. So the whole thing will be divided by 4. After that, we're going to subtract 12 from this quotient or fraction, and then we'll be able to figure out how this instructor quickly calculates the original number. So let's start by simplifying. I like to distribute first. Let's distribute the 4. 4 times x, that's 4x. 4 times 15, that's 60. And then we'll copy the rest of the expression. Now let's start simplifying. 60 minus 8, that's going to give us 52. So this simplifies to 4x plus 52 over 4 minus 12. Now there's several ways you can do this. You could get common denominators, or you could simplify the left fraction. So let's simplify this. I'm going to reduce 4 by 4, that's 1. In the denominator, we'll divide it by 4, that's also a 1. Now a common mistake is to reduce just these two terms. You have to reduce every term in the numerator by 4 in order for this process to work. So I'll have to divide 52 by 4, and that reduces to a 13. So just remember, you have to do all of them or none of them. You just can't do 4 and 4 here. So make sure you do all 3 terms or none of them. This simplifies to x plus 13 minus 12, and this results in x plus 1. So how does the instructor quickly calculate the original number? Well, they just take the result from the student and subtract 1 from it so they know what x is. For example, if the finished number after the student does their calculation is 16, well, their original number was 15. Question 2. At a local farmer's market, 3 purchases were made for the prices shown in the figure. How much does each object cost? There's several ways to do this question. I'm just going to use one method. Notice that if we add these 4 items together, the total price for these 4 items should be equal to $16. And we know that a vase and a cantaloupe is worth $8. So if we remove the vase and the cantaloupe from the $16 total, that would be a subtraction of $8, which gives us $8. Now, what does that imply? Well, that implies that each of these watermelons has to be $4 each. Each of these watermelons has to be $4 each. That's the only way to get a total of $8. So I know the watermelon has to be equal to $4 a piece. For the vase, I know the vase must be $5 because a watermelon and a vase together totals $9. So the vase must be $5. The cantaloupe must be equal to $3. The reason for that is a watermelon is $4 and the only way to add up to $7 is the price of the cantaloupe must be $3. Question 3. Rosa brought the following puzzle from a social media posting and asked about the solution and the use of variables here. How do you respond? Take some time, pause the video, and try this one on your own. After you have tried this on your own, let's go over the solution. I know each cup must be $10 a piece. That's the only way to add up to a total of 30. So we can label on top of this picture, there's 10 for each of these cups. Now 10 plus 2 items should be equal to 20. These 2 cucumbers should be worth 10 together. That means each cucumber individually must be worth 5. And so I could put 5 on top of each cucumber. Now a cucumber plus 2 sprouts should be equal to 9. So this means these 2 sprouts should be worth 4 together, and that implies each of them is worth 2. Now we can solve our problem. We know 5 plus 2 plus 10 gives us 17. So $17 is the total for a cucumber, a sprout, and a cup.